All right, so let's see. So we're going to apply, again, this is a P series. P is 9, which is greater than 1, so this definitely converges. So it makes sense to try to find what it converges to. We want to find a partial sum so that our partial sum is within 10 to the negative third, within 1,000th of the actual sum. What should our n be? So that means, again, our remainder has to be less, it will be less than the integral from n to infinity of 8 over x to the 9th dx. Antiderivative for that would be 8 times x to the negative 8th over negative 8. So we get a little bit of cancellation there. And we want to evaluate that from n to infinity. That's going to end up being the limit as x goes to infinity of negative 1 over x to the 8th, rewriting that, minus negative 1 over n to the 8th. This limit here only involves x, it goes to 0, so then I get my remainder has to be less than 1 over n to the 8th. Let's take n to be, let's take our remainder estimate to be 10 to the negative third, which we could write as 1 over 10 to the third. Flipping both sides, n to the 8th is 10 to the third. So we want the 8th root of that. So our n should be about 10 to the power 3/8. See what we get. And then we'll test it on a calculator. So for my version, 10 raised to the power. Sometimes we need parentheses for these fractional exponents. Okay, that's about 2. It says I only need 2 terms. Let's see, we want the smallest value of n. Because there's a decimal after 2, it could mean we need that third term to get close enough. So testing that out, I'm going to make a function of x. I'm going to call it s of x. And it's going to be my sum from 1 to x of my 8 over n raised to the 9th. And then I want to know what is s of 2? What is s of 3? So nearby that, I want to see what I'm getting. And I'm going to check s of 4 also. So I need the sum accurate to within 3 decimal places. So what do we got? The second partial sum is 8.0156. The next one is 8.016, and then the next 03, 8.01606. So it looks like by the third partial sum, we've settled in on the 3rd or 4th decimal place. But by the second partial sum, we haven't settled yet. So the smallest integer here seems to be 3. So this right here was about 2.4. So we're going to grab the next partial sum and say the smallest n to guarantee 3 decimal places is n equals 3, the third partial sum.